Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 18 for sum. And in this question, we're basically given an array of numbers and we gotta find all of the unique quadruplets that are gonna be equal to our target number. Now, what does that even mean? You see, this is our array of numbers, so we're basically given a bunch of random numbers, and we're also given a target number, and then we gotta find all of the quadruplets that if we add them together, they're gonna be equal to our target number. So for example, if we add these numbers together, they're gonna be equal to 0. As you can see, -2 plus -1, that's -3, and +1, that's -2, and +2, that's 0. So this is gonna be equal to our target number that was given to us here. And same thing for all of these. So we gotta find all of these combinations through our array of numbers. Now let's solve this together, and don't worry, I'll explain everything step by step and then I'll visualize our algorithm so I make sure you fully understand it. These slides took me ages to build, but I hope it provides you with value. Now let's start. So as you can see, this is our array of numbers that was given to us, and we also have a target number. So we gotta find all of the 4 number combinations that if we add them together, they're gonna be equal to our target number. And we also have to make sure that we won't have any duplicate combinations. Like so, as you can see, these are all unique and they don't have any duplicates. And if we add them together, they're gonna all be equal to 0. Alright, so now let's break down our algorithm. We're gonna familiarize ourselves with the structure and then we're gonna visualize everything. So first of all, I think we can all agree that whatever we do in our algorithm, we're gonna need to return something at the end, right? And that something is gonna be our result array that's gonna contain all of the quadruplets that we're gonna have at the end of our algorithm. And then we're gonna need a for loop, and this for loop is gonna have a variable called I, and this I is gonna basically loop through these numbers that we have here. And then inside of our for loop, we're gonna have another loop, and don't worry, I won't finish this video until I make sure you fully understand how to solve this problem once and for all. I'm just currently explaining the structure, and then we're gonna visualize the whole algorithm together. So inside of our second loop, this is also gonna be a for loop, and it's gonna have a variable called j, and we're gonna start from I plus 1. So far we've had a for loop, and its variable is gonna be I, and as you all know, it's gonna keep incrementing on each loop of our for loop, because that's just how for loops are. And then inside of our for loop, we're gonna have another for loop, and the variable for this one is gonna be j, and we're not gonna say j is equal to 0, we're gonna say j is equal to I plus 1. So whatever I is, j is gonna be one number ahead of it. And then inside of our second loop, we're gonna have another variable, and that's gonna be called p, and p is gonna be equal to j plus 1. Simple as that. So whatever j is, p is gonna be one number greater than j. And then we're gonna have this variable called k, and it's gonna be equal to numbers.length minus 1, meaning get the length of our array minus 1. So 1, 2, 3, 4, 5, 6. 6 minus 1, it's gonna be 5. This is just a fancy way to say it's gonna be equal to the index of this number, and the index of this number here is gonna be 5. And then inside of our second loop, we're gonna have our final loop, and inside of this loop, we're gonna calculate our sum. So we're gonna say the number that our I variable is pointing to, so numbers of I, for example, if I is 0, it's gonna be pointing to this one here, plus the number that our j pointer is pointing to, for example, if j is 1, it's gonna be pointing to this 0 here, because this is the number with the index of 1, plus the number that our p variable is pointing to. So for example, if p is 2, it's gonna be pointing to this number here, so this nums of p is gonna be this minus 1 here, plus the number that our k variable is pointing to, which is gonna be the last number, which is gonna be this 2, and we're gonna add all of these together and we're gonna get a sum. So for example, 1 plus 0 plus minus 1 plus 2, whatever the result of that addition is gonna be, our sum variable is gonna be equal to that. Simple as that. And then whatever our sum variable is gonna be equal to, we're gonna say if sum is equal to our target, and our target is currently 0, do the following. We're gonna say add the combination that we have to our result. So we're gonna add nums of I, nums of j, nums of p, and nums of k to our result, because we wanna know which numbers are actually equal to our target number. So we gotta return that at the end. And then we're gonna say increment our p and decrement our k. You're gonna see how all of these are gonna work in the visualization, don't worry. And then we're gonna say else if our sum number was greater than our target number here, decrement k, and else increment p. And then at the end, we're gonna return our results. Now let's start the fun part, which is gonna be the visualization of our algorithm. And as we all know, our target is 0. So first of all, let's take care of that. So target is equal to 0. So let's type 0 here instead of target to make things more clear. And now for this algorithm to work, we gotta first sort our numbers here. So whatever our array of numbers is, we gotta sort it like this. So it's the same array We just sorted it from the smallest number to the biggest number. Alrighty, so in the beginning of our code, we're going to enter our for loop here, and we're going to initialize our I to 0. So I is going to be equal to 0. And then we're going to enter our second loop. And inside of our second loop, we're going to define j. And j is equal to I plus 1. So j is going to be 1 because I is 0. So 0 plus 1 is going to be 1. And then we're going to define p, and p is going to be equal to 2 because j plus 1 is equal to 2. And then we're going to define our k, and our k is going to be 5 because numbers.length is going to be 6 minus 1, that's going to be 5. And then we're going to get to the fun part, and we're going to enter our final loop, and we're going to calculate our sum. So let's do that. How are we going to do that? Well, as you can see, each one of these here is going to be pointing to a number. So as you can see, I is equal to 0. So numbers of 0. So the number at the index of 0 is going to be this minus 2 here. And j is going to be 1. So the number at the index of 1 is going to be this minus 1 here. And the number at the index of 2, which is going to be our p, is going to be this 0 here. And the number at the index of 5 is going to be this 2. So minus 2 plus minus 1 plus 0 plus 2, that's going to be minus 1. And again, we got these numbers from here and we just added them together. So now our sum is equal to minus 1. Is sum equal to 0? And again, remember 0 is our target. Nope, it's not. Is sum greater than 0? So is sum greater than our target? Nope. So we're going to fall inside this else and we're going to increment p. As you can see, p got incremented and we started our loop again. And now because p is equal to 4, we're going to be pointing to this number here. So the number that our p variable was pointing to has changed because p incremented. So now we're going to repeat our loop, this final loop here, and we're going to calculate our sum again. So we're going to say minus 2, which is the number that our I variable is pointing to, plus minus 1, which is the number that our j variable is pointing to, plus 1, which is the number that our p variable is pointing to, plus 2, which is the number that our k variable is pointing to. The sum of this is going to be 0. And when you look at that, our target is 0. So we're going to say if sum is equal to 0, which it is, as you can see, our sum is equal to 0, add the combination to our result. So let's do that. This is our result. Let's add our combination. Our combination is going to be the numbers that we found that are equal to 0. So minus 2, minus 2, minus 1, minus 1, 1, 1, 2, 2. And then we're going to say increment p, and then after that, decrement k. So let's do that. P is 5 and k is 4. And now we're going to repeat our loop. But as you can see, the condition for this loop that we have here, so the condition for our final loop is going to be keep on looping as long as p is smaller than k. And as you can see, because we incremented p and decremented k here, our p, which is 5, is greater than our k, which is equal to 4. So we're going to break out of this loop and we're going to repeat our second loop, which is this white loop here. And j is the variable for our for loop. And in the next round, it's going to increment because that's just how for loops work. So j previously was equal to 1. So now j is equal to 2 and p is equal to j plus 1. So that's going to make p be equal to 3 and k is equal to num_length minus 1. So it's going to make k be equal to 5. And as you can see, because our numbers changed, they're now pointing to different numbers. Our I is still the same, but j and p have changed because j is the variable for our for loop and it got incremented, and because p is always one number greater than j. So because j changed, p also changed, but k remained the same thing. And then after we've updated these, we're going to enter our final loop and we're going to calculate our sum again. So minus 2, 0, 0, 0, 0, 2, 2. And the sum of this is going to be equal to 0. So is sum equal to our target, or is sum equal to 0? Yep, it is. So add our combination to our result. So let's do that. As you can see, minus 2, 0, 0, 0, 0, and 2, and 2. And then we're going to say increment p and decrement k. So let's increment p and decrement k. So p is going to be equal to 4 and k is going to be equal to 4. And now we want to repeat our loop. But the condition for this loop is that we're going to keep on looping as long as p is smaller than k. And as you can see, p is equal to k now. So we're going to break out of our loop and we're going to come back to our second loop and we're going to keep on incrementing j. So as you can see, j is now 3 and p is now 4 because p is one number greater than j. And our k is still equal to 5 because it's equal to nums.length minus 1. So as you can see, we're pointing to these numbers here, and we're gonna enter our final loop again, and we're gonna calculate our sum. So minus 2, plus 0, plus 0, plus 1, plus 1, plus 2, plus 2, and that's equal to 1. So our sum is 1. Is our sum 0? Nope. Is our sum greater than target or greater than 0? It is. So decrement k. So let's do that. K is now 4. And then we want to repeat our loop, but p is not smaller than k. As you can see, we decremented k, and k and p are now equal. So we're going to break out of our final loop, and we want to repeat this loop, but the condition for this loop here is that we want to keep on looping as long as j is smaller than nums.length minus 2. Nums.length is 6 minus 2, that's 4. So we want to keep on looping as long as j is smaller than 4. And if we increment j, because in the previous round, j was equal to 3. And if we increment j is going to become 4, and this condition is not going to be true. So we're going to break out of this loop, and then we're going to come back to our first loop, and our I is going to increment. So now I is minus 1, and then we're going to enter our second loop. J is going to become 2 because I is 0 plus 1, that's 2. P is going to be 3, and K is still going to be 5. And they'll be pointing to these numbers here. So as you remember, in the previous rounds, I was always 0, and we were always pointing to this minus 2 here. So now that we've taken care of that and we got these solutions, we're going to explore other numbers. So our I is going to be minus 1. After we've updated these values, we're going to enter our final loop again, and we're going to calculate our sum. So minus 1 plus 0 plus 0 plus 2. As you can see, it's going to be equal to 1. So is sum equal to 0? Nope. Is sum greater than 0? It is. So decrement k, let's do that. So now k is pointing to this number here because it got decremented, and this is the number with the index of 4, and k is equal to 4. So let's calculate our sum again. Like so, minus 1, 0, 0, 0, 0, and then 1, 1. And this is going to be equal to 0. So is sum equal to 0, which is our target number? Yep, it is. So let's add our combination to our result. Let's do that. As you can see, minus 1, 0, 0, 1, 0, 0, 1. And then we're going to increment p and decrement k. So let's do that. P is going to be 4 and k is going to be 3. And we want to keep on looping, but the condition for this loop is that we're going to keep on looping as long as p is smaller than k. And now p is equal to 4 and k is equal to 3. So this condition is not going to be true. So we're going to break out of it, and we're going to repeat this loop. So j is going to get incremented in our loop, and then p is going to be 4 and k is going to be 5. Because j is the variable for our for loop, and it's going to keep incrementing on each round. So now our variables are going to be pointing to these numbers here. We're going to enter our final loop. We're going to calculate our sum. Minus 1, plus 0, plus 0, plus 1, plus 1, plus 2, plus 2. And that's going to be equal to 2. So is sum equal to our target, which is 0? Nope. So is sum greater than our target? It is. So decrement k. Let's do that. Now k is equal to 4. And we want to keep on looping. But again, p is not smaller than k anymore. So we're going to break out of our final loop, and we want to repeat our second loop. But if we increment j again, j is going to be equal to 4. And here we're saying keep on looping as long as j is smaller than nums.length minus 2, which is 4. So this condition is going to become false. And we're going to break out of our second loop, and we're going to go back to our first loop, and I is going to be incremented like so. Now that I is updated, we're going to enter our second loop again. Our j is going to be equal to 3 because j is equal to I plus 1. 2 plus 1 is 3. Our p is going to be equal to 4, and our k is going to be equal to 5. Then we're going to enter our final loop. We're going to calculate our sum. So 0 plus 1 plus 2, as you can see, because our variables are pointing to these numbers here, and our sum is going to be equal to 3. So is sum equal to 0? Nope. So is sum greater than 0? It is. So let's decrement k. Let's do that. If we do that, we're going to break the condition of this loop. So we're not going to repeat this loop, and we're going to break out of it, and we're going to come back to our second loop. But j is already 3, and the condition of this loop is that we're going to keep on looping as long as j is smaller than 4, because nums.length minus 2 is equal to 4. And if we increment j, because j was previously 3, and if we enter the next round, we got to increment it. And if we do that, we're going to make this condition be false. So we're going to break out of our loop, and we're going to go back to our first loop. And the condition for our first loop is that we're going to keep on looping as long as I is smaller than nums.length minus 3. Nums.length is equal to 6. So 6 minus 3, that's going to be 3. And if we increment I again, I is not going to be smaller than 3 anymore. So we're going to break out of our first loop and we're going to return our result, and this is going to be our answer. This is our solution, and now let's code this in the simplest way possible. Alrighty, so first of all, let's define our result variable, and that's going to be equal to an empty array. And then we're going to define our for loop, and we're going to say for let I be equal to 0. We want to keep on looping as long as I is smaller than nums.length minus 3, just like we saw in the slides. Then I++, and we're going to enter our loop. And then inside of this, we're going to define our second loop, and we're going to say for let j be equal to I+1. And we want to keep on looping as long as j is smaller than nums.length minus 2. And then we want to keep on incrementing j. Then we're going to enter our second loop. And here we're going to define our p variable, and that's going to be equal to j+1. And then we're going to define our k variable, and that's going to be equal to nums.length minus 1, just like we saw in the slides. And then below these, we're going to define our final loop, and that's going to be a while loop. And we're going to say keep on looping as long as p is smaller than k. Then we're going to enter our final loop, and let's scroll down a bit. We're going to define our sum. So let sum be equal to nums of I plus nums of j plus nums of p plus nums of k. So this is going to give us our sum. And then we want to check if our sum is equal to our target. If it is, we want to, let's scroll down a little bit, add our combination to our result variable here. So let's do that. Result.push. We're going to have an array because, as you can see here, our answers are inside of an array. So we basically have an array of arrays. We're going to say nums of I, comma, nums of j. I zoomed out a little bit to make things more clear. So we have nums of I, nums of j, and then nums of p, and then nums of k. So we've added our combination to our result here, and then we're going to say increment p and then decrement k. And then below this, we're going to say else if our sum was greater than our target, we're gonna decrement k. Else, we're gonna increment p. And at the end, we're gonna return our result. So this is our code here, but there's one thing that we need to add. And as you can see, we were told that we need to return unique quadruplets, right? So we gotta make sure that we won't have any duplicates in our answers. So to do that, here, when we define our I, we're gonna say if nums of I is equal to nums of I minus 1, continue. So we're basically saying if I is equal to its previous value, meaning if we incremented I and in the previous value I was 0, and after we've incremented it, I is still 0, that's gonna cause having duplicates in our answer. So we don't want that. We're saying continue. And this continue here is like saying skip everything that's below me and go to the next round of my loop. So whatever the loop above of our continue is, we're gonna move to the next round. And this is the loop that we have. So we're gonna skip everything here and we're gonna move to the next round. But if you think about it, our I in the beginning is gonna be 0. So I minus 1 in the first round is gonna be undefined. So here we're gonna say if I is greater than 0 and the condition that we had. So this is gonna make sure that our I is greater than 0, then we're gonna check and see if our I is equal to its previous number. If it was, we don't want it and we wanna continue because we don't wanna have duplicates in our answer. Now you might ask, we've taken care of I and we're checking if I is equal to its previous value, but what about j? Well, you are completely right. If our j is equal to its previous value, that means we're gonna have a duplicate. So let's say if nums of j is equal to nums of j minus 1, continue. Just like here. And then we gotta also check if it's gonna be the first round. So in the first round, we don't wanna check this because in the first round, our j is gonna be fresh and it wouldn't have any previous values because it's literally the first round. So we're gonna say j greater than I plus 1 and then and. So this is saying if j is greater than this value here, meaning if it is greater than the value it got initialized with, just a fancy way to say if we're not in the first round, check this. And if we do have the same number, meaning if we do have a duplicate number, continue. Now you might say, what about p and k. Those should not also be duplicates, right? Well, you're completely right, because we gotta also check that when we increment p and decrement k, if their new value is equal to their previous values, we don't want to check that because we've already done that, right? And therefore we want to move to the next number, so we make sure the values that our p and k represent are all unique numbers. So here we're gonna say, after we've added our combination to our result here, we're gonna increment p and decrement k. But we want to say, if we increment p and p is still equal to its previous value, just keep on incrementing p because we don't care about that. We've already checked that number. And same thing for k. So we're gonna say while our nums of p is equal to nums of p plus 1, because remember, we're incrementing p, so we're gonna have plus 1 here. If they are equal, we're gonna say keep on incrementing p because we don't care. And same thing for our k, we're gonna say while our nums of k is equal to nums of k minus 1, because as you can see, k starts from the last index and we keep on decrementing. So we want to check if the new value of k is equal to its previous value. So if that's the case, we want to decrement k. We don't care about that number and we want to keep on decrementing k. Again, we're doing these 4 lines to make sure that we don't have duplicates. So every time we're saying, if the values are equal, continue or skip. As you can see, same thing here, same thing here. We're gonna keep on incrementing and we're gonna keep on decrementing, and that's literally like saying skip. This is all of our code, but remember, we said our algorithm is gonna work if our numbers are sorted. So let's sort them. So nums is equal to nums dot sort a and b, and this is gonna be a minus b. And this is just how we sort arrays in JavaScript. So this is gonna sort our array of numbers. Now let's run our code and see if we're gonna pass our tests. 1, 2, 3, yep. As you can see, all of them are passed. And now let's submit it and see if we're gonna pass. Yep, as you can see, and we're beating 94% of all of the other submissions. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.